In this lesson on sequences and series, we're going to have a look at the proofs of the sum formulas. We are firstly going to look at the proof that the formula in the bottom right corner can be used to calculate the sum of an arithmetic series. We're going to start off by mentioning all the variables that we're going to use. So we're going to say let A be the first term of the row and D the constant difference. So if we want to calculate the sum of n terms, we're going to start off with term 1. And we're going to add term 2, which will be the first term plus the constant difference. Then we'll have term 3, which is the first term plus 2 times the constant difference. And we can continue like this right up to the end. Now, we need to remember that the last term can be calculated by saying the first term plus 1 less than the number of terms times d. So I'm simply going to use Tn and say right at the end my last term is term Tn. That means the term just before that would be Tn minus d. I'm going to rewrite this whole equation, but on the right I'm going to start back to front. Now I'm going to add up the two equations. On the left, I will have Sn plus Sn is 2Sn. On the right, when I add up the first two terms, I will get A plus Tn. If I have a look at the second group of terms, I will also have A plus Tn because d minus d is 0. And this will continue all the way down to the end. If I look at the second last term in each equation and add that up, I will have Tn plus A, or I'm going to write it as A plus Tn, because once again minus d plus d is 0. And right at the end, T plus A, which I'm going to write as A plus Tn. If I now have a look at my right-hand side of the equation, you will see that every single term is A plus Tn. We added n number of terms at the beginning, so we have n times exactly the same term. I just need to remember that Tn has its formula A plus n minus 1d, and I need to substitute that back in. And all that's left to do is to divide by 2. So I'm going to have n divided by 2 and then simplify inside my bracket. And here I have the formula for the sum of an arithmetic series. Now we're going to prove that the formula in the bottom right, once again, can be used to calculate the sum of a geometric series. Once again, we start off by naming the variables that we're going to use. So we're going to say let A be the first term and R be the constant ratio. If I'm now going to get the sum of n terms in a row, I'm going to start off with my first term. My second term will then be A multiplied with the constant ratio. Third term, A multiplied with the constant ratio twice. And we can continue like that right up to the end where we have A multiplied with the constant ratio 1 less time than the number of terms. I'm going to take this same equation and multiply with R straight through. If you look closely, you will now see that there are similar terms in these two equations. So I'm going to rewrite the equations so that these similar terms are underneath each other. I'm going to subtract these two equations. So I'm going to have r s to the power of n minus sn on the left. On the right, I have 0 minus a, which is minus a. ar minus ar is 0. And that will continue to be 0 right up to our second last term. And our last term will be ar to the power of n minus 0, which is ar to the power of n. All right, I'm just going to rewrite it. It has ar to the power of n minus a. And now you'll see that the left and right can both be factorized. So on the left, I'm going to take out Sn as my common factor. I'm left with r minus 1. And on the right, I'm going to take a out as a common factor. And I have r to the power of n minus 1. All that's left for me to do is to go and divide on the right with the r minus 1.